Welcome back to our lecture. And the next service that we're going to discuss is the Elastic Compute Cloud, or EC2. EC2 is one of the most important services that we'll talk about in this course because we use this service in many of our class projects. EC2 is the service that provides you with compute capacity in the cloud. It's your server in the cloud. And we use EC2 as a building block component when building out our cloud architectures and platforms. We use it to support applications and services running in the cloud. And actually, AWS uses EC2 under the hood as a building block component for many of the other managed services that it delivers to customers. EC2 servers are what we call instances, are basically virtual machines that AWS manages for us. And these virtual machines are running on top of a highly customized version of the Xen hypervisor. When you create an EC2 instance, you have a couple different deployment options to choose to pick from. By default, when you deploy an EC2 instance, you are using an on-demand deployment option. With an on-demand deployment option, essentially you're paying a fixed rate for that EC2 instance on a per second basis. So you're paying for every single second that EC2 instance is running. And you can turn this instance on or off, and when you turn the instance off, then you no longer pay charges for the instance running. As it turns out, you do pay some charges. You pay for the amount of storage space that instance is consuming, but you're not paying the cost to actually run the EC2 instance. The on-demand deployment option makes a lot of sense for, I'd say, probably most of the workloads, most sort of general workloads, especially workloads that might be short-term, sort of unpredictable. You're not really sure how long you're going to run the EC2 instance, and so the on-demand deployment option makes a lot of sense. The second deployment option is what we call the reserved deployment option. And with the reserved deployment, you are basically contractually bound to using an EC2 compute instance for a certain amount of time. And so what you're telling AWS is that you're willing to use an EC2 instance for the next 1 to 3 years. And in exchange, AWS is going to provide you with a highly discounted rate for using that instance. And so this makes sense when you have an EC2 instance that you're going to run for a long period of time. You've got some sort of predictable workload. Maybe you're running a database server for a platform and you know that you're going to need to host that platform for the next couple years. There's an option that you can enable for reserved deployments, and that is to select the convertible option, which allows you to upgrade a server to a larger instance. So when you make an instance reservation, when you use the reserved deployment option, basically you're telling AWS that you want to use a certain sized image for a particular amount of time. And we'll talk about server sizes here in a bit. But there might be cases where, like, you start off using a smaller instance size, a smaller server, and then later on you want to upgrade to a larger server because your business has grown and your needs have grown. And that's where the convertible option makes sense. The third deployment option is to utilize what's called a spot deployment, which is a really innovative deployment model. With a spot instance, what you're essentially doing as a customer is you are bidding for compute capacity. So you are bidding for available compute in the open marketplace. You can imagine that AWS has a certain amount of compute capacity that is not being utilized at any given time. I mean, they're serving millions and millions of customers, and they have a substantial amount of compute capacity in place to support their customers, and they're always installing more and more capacity. So at any given time, they're going to have an extra amount of compute capacity that's not being utilized by anyone. And you can actually bid for this compute capacity, just sort of like you're buying a stock in the stock market. You're making a bid for what you're willing to pay for that available capacity. And if your bid is acceptable, then AWS will provide you with the computing capacity at that particular price. Now, the downside is that if AWS encounters a customer that's willing to pay full price for that EC2 compute capacity, then they will yank the capacity away from you, effectively terminating your EC2 instance, and they'll give that capacity to a customer that's willing to pay the full price. So that's the sort of downside, is that yes, you can use this capacity for really, really cheap rates, but you've got to realize that it could be taken away from you at any time. And in a traditional world where we were running workloads on servers for weeks, months, and years, this idea of like spot capacity seems kind of insane. I mean, why would you deploy your application and run a service on a system that might be terminated at a moment's notice? Well, you got to change your mindset. When working with the cloud, you're working with dynamic infrastructure and services. We'll have the ability to automatically deploy our services into cloud infrastructure. We have the ability to automatically provision EC2 instances and quickly get our services up and running. So this is all automated behind the scenes. And imagine you had a software platform where you needed to spin up, dozens, maybe even hundreds of workers that were running in parallel and supporting some critical processes in your platform. It might not matter if those workers are just inadvertently killed off by AWS, because you can just simply quickly replace them with another worker, and you might only need these workers to run for a few minutes at a time. So it's this world of really dynamic infrastructure and our ability to automate our applications that makes spot instances really a really feasible option for us. I mentioned that you have different sort of sizes of servers. AWS calls these EC2 Instance Types, and there are many, many different types of servers that are available to us. And each of these instance types has a different amount of CPU and memory. Some of these instances are optimized for faster network connectivity. Some of them are optimized for heavy, disk I/O and storage. So the idea is that you kind of choose an instance type which aligns with your particular service need. If you're doing like just development and testing work, then something like a T2 or T3 instance type can make a lot of sense, because they're very cheap, very inexpensive. And we'll use these instance types quite a bit throughout this course, because generally we're just doing very simple training type exercises, and we want to keep our costs down. If we're doing sort of general purpose computing workloads, we're supporting a typical application, maybe even databases, sort of smaller size databases, we might use an M4, M5 instance. Those are your sort of general purpose computing instances. If you have, let's say, like an in-memory database application that you want to support that's highly memory intensive, then you would use an R4 or R5 type of instance. I'm thinking of like in-memory data analytics type systems. If you need to do like maybe you're running Hadoop, you have to support HDFS. You have in storage I/O as a principal concern. Then maybe you would look at something like the H1 or D2 instance types. So the point is that for any type of workload that you need to support, there is an instance type that's available. If you look at the bottom of the slide, there's a link that I provide to a really useful website that allows you to compare the different features of these instance types and the current pricing for these types, because the pricing can vary dramatically. And within each of these instance types, you'll find different sizes. So for example, you can spin up a T3 micro instance, or you can spin up a T3 large instance. And a micro versus a large instance will have a different amount of CPU capacity and a different amount of memory capacity that's available. So that's another way to, not only the instance type, but the size of the instance type is something that we would align with our workload. When we create an EC2 instance, we have to start with some sort of template. You can imagine, like, if you had a bare metal physical server and you were to start configuring that server, the first thing you would do is you would load in an operating system, and the operating system might have a set of applications and configurations that are sort of baked into it. In an EC2 instance, we start with an AMI, an Amazon Machine Image. That's the template that defines the base operating system and applications in configuration for the EC2 instance. And there are a couple different ways that we can get AMIs. Amazon curates a number of AMI images, and we'll use some of those in this course. There are community provided images, so you or anybody else can create an AMI and make it available to the public. So for example, I've created a number of AMIs in this course that students will use in exercises. So that's, those are considered community provided images. You got to be careful when you're using a community image, because unless you know who has created that image, there is really no way of knowing exactly how it's configured, and somebody could have done something malicious with that image. And so you need to be very careful with community images. There are commercial images that are available to you. There's something called the Amazon Marketplace. So third-party software firms have created commercial images which are available to you. So images from companies like Canonical or Microsoft or SAP or whoever. Just about any software that you would buy commercially today is generally available on some sort of commercial image in the marketplace. And then finally, like I mentioned, you can create your own images, and you can make those images private, which is very common. If I'm working in an organization, generally my organization is creating its own set of AMIs, and those are curated by the organization, and those are completely private. Nobody else in the world has access to them, and they're only consumed within the organization. EC2 is a regional service. So when we create an EC2 instance, as we'll see here shortly, that instance only exists within a specific region. And actually it goes beyond that. That instance only exists within a specific availability zone within a region. So, remember with S3, that's also a regional service, but our S3 data is replicated to multiple availability zones. That's not the case with EC2. When we stand up an EC2 instance, we're standing up one single virtual machine that's running on a physical server somewhere in a single availability zone within a single region. So EC2 instances only exist within a particular region. And the AMIs, these templates that we use to create EC2 instances, only exist within a specific region as well. So if I create an AMI, this template, I might create it in US East 1. But if I want to spin up an EC2 instance in US West 1, I can't use the AMI that's located in US East 1. I'd have to actually copy that AMI from one region to another. So that's just something else to keep in mind. AMIs are region specific. When I launch an EC2 instance, that EC2 instance is going to use the AMIs. You can use this template to install an operating system instead of applications and configuration. But where is it going to install that stuff to? Well, it installs the operating system and the data to something called the Elastic Block Storage, or EBS. Elastic Block Storage is network addressable storage that is attached to our virtual server. And from the standpoint of our virtual server, an EBS volume looks like a hard drive. So when you access your EC2 instance and you look at the file system, that file system is stored on EBS. And the operating system, if it's Windows or Linux, sees that EBS volume like it, and it treats it as if it is like a hard drive. So EBS volumes are what we call block storage, and we can use them to support our traditional file systems and databases. Remember, we looked at another storage option, S3. S3 is object-based storage. We can't use that to store file systems. We can use it to store individual files. We can't initialize a volume in S3. EBS, on the other hand, looks and acts more like a traditional hard drive, and that's something where we can store our file systems. When we create an EC2 instance, it uses EBS, and it creates a storage volume within EBS. The data in that storage volume is actually replicated within the single availability zone, and that provides us with greater availability. And it makes it much less likely that we would lose access to that storage volume. So remember, the EC2 instance is running within one availability zone. The EBS volume, this hard drive, this network hard drive, is also located within the same availability zone. But the data on that hard drive is replicated across multiple systems to mitigate the possibility of the EBS volume just simply disappearing, or mitigate the possibility of us losing the data. Keep in mind, though, that if for some reason we lost access to the availability zone, like there was some sort of catastrophe or fire or something that wiped out that availability zone, it would then wipe out that data. We would lose access to the data and to that EC2 instance. So you'll see later in the course that in order to build highly resilient and reliable infrastructure, we'll typically deploy multiple EC2 instances, and we'll deploy those instances across multiple availability zones within a particular region. And in some cases, we'll even deploy instances across multiple regions for truly geographic diversity. When we create an EBS volume for our EC2 instance, we can select from a couple different volume types. And again, these are designed to align with particular use cases. In most cases, you'll just use the general purpose SSD drives, or also known as GP2. This is highly available storage, 5 nines of high availability, and it's fast, up to 16,000 IOPS per volume. So it's using SSD drives, which are very, very fast drives. These are the same sort of drives that you find in in any sort of modern system that you would buy, and they support most general use cases. If you need something faster than that, then you can use provisioned IOPS SSD, or what's called IO1. This is for very, very high speed disk IO applications. So think database here. If you got a highly transactional relational database that requires heavy IO, then you would want to provision the IO1 volume type. If you have, let's say, some sort of like streaming application where it's not really it doesn't require sort of dynamic reads, then you might use the throughput optimized HDD storage, or what's called ST1. And this is based on magnetic storage. So if you have some sort of streaming data that you need to support, that might make sense. And then finally, the cheapest possible option is what we call cold HDD, which is the old traditional magnetic storage. And many volume types don't actually support this, or many instance types don't support this anymore. But you'll find some that do, and there are use cases for this. So if you have infrequently accessed data, or if you're just simply looking for the cheapest possible block storage for your EC2 instance, then the cold HDD volume type might make sense. When we're working with our EBS volumes, we're storing our data on those volumes, and oftentimes we'll want to back them up. And one way to do that is to leverage a capability called EBS Snapshots. Now, a snapshot is essentially a point-in-time copy of an EBS volume. So you can think of it as like it's snapshotting the state of that hard drive, of that network hard drive, and it stores a copy of that data in S3. When you take EBS snapshots, they're incremental. So the first time you take a snapshot of an EBS volume, it might take a little bit longer, but then subsequent snapshots generally happen faster because we're just snapshotting the delta of changes that have taken place within the storage volume. The big benefit with EBS snapshots is that they're generally pretty fast. We can quickly take a snapshot of a volume before we apply an update to a system, or we can take snapshots on a periodic basis, every day or every 6 hours or something, in order to make backup copies of our data volumes for recovery or like disaster recovery purposes. Oh, one thing I didn't mention is that you can actually take those EBS volume snapshots and then turn them into AMIs. And so we might look at that in the hands-on segment of the lecture, and I'll show you how to do that. Another storage option that's available to you is called Instance Store. And what's interesting is that Instance Store is actually the original data storage option for EC2 instances. Way back in the day when EC2 was launched, like back in 2005, 2006, Instance Store was really the only option that was available to you. What Instance Store really means is that the virtual machine is using the local storage that's on the physical host, on the physical virtual machine host. So your EC2 instance is running on some physical server out there in the cloud, and that physical server has hard drives mounted to the server, like literally contained within the server. And the Instance Store is carving out a portion of that storage and making it available to the virtual machine that's running on the server. The benefit with Instance Store is that the storage access can be really fast. simply because instead of communicating with storage over a network connection, an Ethernet network connection, you're communicating with storage that's located on the actual same physical machine as the virtual machine. So the latency would be far less. The problem with an instance store is that it's ephemeral. So if you were to ever stop the EC2 instance, then the storage volume just simply disappears forever. So it's not storage that you would want to use to persist data for long periods of time, or at least you wouldn't want to persist data that is intended to outlive the EC2 instance. You would want to store that data in S3 or EBS or some other storage, or maybe like a database. When you create an EC2 instance, when you launch the instance, which you'll see in the hands-on segment, oftentimes you want to be able to bootstrap applications or the configuration of that virtual machine. So you start the machine by using a template, and the template's going to have an operating system instead of applications and services on it. But you might want to sort of programmatically bootstrap that machine in a particular way when launching the server. And you can do that using EC2 User Data. So User Data is essentially a set of shell script commands which are going to be executed on the instance during the boot phase, during the launch phase of the instance. The shell script commands that you provide are going to be executed with root access on the machine. So you can basically do anything that you need to do, anything that's scriptable via shell. And again, the real benefit with EC2 User Data is it allows you to automate some of the configuration and installation of the EC2 instance at launch time. And we'll see several examples of that throughout this course. Here's an example of like EC2 User Data, where we have a small shell script. In this case, it's related to a Mongo database, and we're passing in some environment variables into that Mongo database, server, and that will probably impact the way that the service runs on that particular system. When we create EC2 instances, generally, oftentimes we're creating multiple EC2 instances within our account. And we want to be able to control how those EC2 instances are accessed. In a traditional environment, if we were to provision a physical server on our network, we might configure a firewall system. And that firewall system is going to determine who can access that server over what ports. We can do the same thing with EC2. Instead of configuring a firewall, we're going to configure a security layer around our EC2 instances called security groups. When you configure a security group, you're essentially defining a set of IP addresses and network protocols that are allowed to communicate into and out of our EC2 instance. You can think of it as kind of like a basic layer 4 firewall system. Now, if you launch an EC2 instance and you sort of use a default security group, then by default, all of the inbound traffic to that EC2 instance is going to be blocked. And all of the outbound traffic from that instance will be allowed. So essentially, like if you were to just like launch an instance using a default security group that you hadn't customized, then nothing would be able to communicate into the EC2 instance, but an application that's running on the instance would be able to communicate out. And there's an important point to be made here in that security groups are what we call stateful, which means that any request that is made and that is allowed through a security group, any request that comes in, the corresponding request is going to be allowed out by the security group. And it doesn't matter which direction the request is coming from. So in other words, if I configure a security group that allows incoming HTTP traffic, which is web traffic, on port 80, I don't have to configure a corresponding rule that says that port 80 traffic is allowed out from the security group. Because when I say that the security group should allow incoming traffic on port 80, then the security group will automatically allow the response from that traffic to go out of the security group. And the same thing is true of outbound connections. So if I say that applications that are running on a security group can communicate out on port 80, I don't have to create a corresponding rule saying that it should allow connections on port 80 incoming, because the security group will automatically allow the responses to those outgoing requests to come back in. So this security group is stateful. We'll look at another network feature later in the course called ACLs, network ACLs, that are not stateful, and those are stateless. And it's important so that you don't confuse the two. So again, security groups are always stateful. If you allow a request to go out or come in, then the security group will automatically allow the response to go out or in, depending upon where the request is coming from. So when you set up an EC2 instance, the instance has to have, or it has to be associated with at least one security group. And an instance can actually be associated with multiple security groups, up to 5 different security groups at any time. And so, which is very common. So, there's this association concept where an instance is always going to be associated with one or more security groups. And you could have multiple instances which are associated with the same security group. But again, the security group is really just defining the rules of what traffic is going to be allowed in and out of a particular EC2 instance. You can say that traffic is allowed from a particular network range, and define a particular network block in what we call CEDAR notation. In some cases, you'll see where we create security group rules and we're saying that we're going to allow incoming traffic on, let's say, port 80, which is web traffic, from 0.0.0.0/0. Well, that CEDAR notation, which is 0.0.0.0/0, essentially means everywhere. That represents the entire internet. We're saying that this traffic is going to be allowed to, go into the instance from everywhere on the internet. We could also say that we want to allow incoming traffic on a certain port from another security group. So in that case, you can see an example here where we have this database security group, and it has a security group rule which says that we're going to allow port 3306 traffic, which is MySQL traffic, from any instance associated with the web security group. So that's another way that you can define security group rules, and it's a way that you can kind of tie one security group to another security group. A couple last remaining items. When you are deploying EC2 instances, you have the option of deploying an instance into something called a placement group. And there are two different types of placement groups that are available. One is what we call a cluster placement group. And the idea here is that if you might have a software application or a platform which is going to require multiple EC2 instances, and you want to ensure that those EC2 instances are placed close together in a single availability zone. And the purpose being that you want to minimize the network latency between those EC2 instances. So think of like high performance computing applications or big data, Hadoop sorts of applications where you need the virtual machines, the EC2 instances, physically located very, very close to one another and tied together over very low latency, high speed network connectivity. You want to cluster them together inside a cluster placement group. And of course, you're going to spend more money for this. You're going to pay more to have these instances located closer together. But again, it's all about supporting a particular use case. Another option is that you can use what is called a spread placement group. And the idea here is kind of like, in some ways, sort of the opposite of the cluster placement group. The idea with a spread placement group is that you have a set of EC2 instances, and you want to always ensure that these instances are running on distinct physical hardware hosts. You never want these instances to ever be running on the same physical host machines. And so you might do this because you're running like a business application, and you want to make sure the applications are never end up on the same physical server, because if a physical server were to fail, then it might take out more than one business application, and that could cause a serious problem for you. So a spread placement group isn't something I've used before. If you're building a cloud native application, I think there's much better architectures for building resiliency. But if you have more of a traditional application, then a spread placement group might make sense for you.